Have you ever felt like there's a secret code hidden in the world all around us? Well, when it comes to shapes, from a simple cardboard box to the Great Pyramids, there absolutely is, and today we're gonna crack it.
So let's start with a question. What on earth does a simple camping tent have in common with the epic pyramids of Giza? I mean, yeah, they're both pointy, but it goes so much deeper than that. They actually follow the same hidden set of rules, a kind of mathematical language. And trust me, by the end of this, you're going to be speaking it fluently. So our first stop on this journey is a shape you see literally everywhere. Think about a shoebox, a book, even a skyscraper. It's the sturdy, reliable workhorse of the 3D world. So let's get started with Act 1 and meet the prism.
So what actually makes a prism a prism? It's really simple. It just boils down to two key things. First, you've got to have two bases that are the exact same shape and are parallel to each other. And second, the sides connecting those bases, they have to be rectangles. And that's it. You get those two things right, you've got yourself a prism.
And here's a really cool part. Naming them is incredibly easy. You don't need some fancy math degree. You just look at the shape of the base. If the base is a triangle, boom, it's a triangular prism. If it's a pentagon, yep, you got it, a pentagonal prism. It's a super logical system.
Okay, so we've been introduced. Now it's time to really dig in. We're going to break this shape down piece by piece and uncover that secret code I was talking about. You could even call it its geometric DNA.
Every single prism is built from the same few components. You've got the two bases, right, the top and the bottom. Then you have the rectangular sides connecting them. Those are the lateral faces. The lines where any two faces meet, we call those the edges. And finally, the pointy corners where all the edges come together, those are the vertices. Pretty straightforward, right? Now let's see how these all relate to each other.
All right, check out this table. We've done all the counting for you. Let's take a triangular prism, where the base has 3 sides. We get 6 vertices, 9 edges, and 5 faces. Now look what happens with a square prism, where the base has 4 sides. The numbers all jump up. Do you see a pattern emerging here? Feel free to pause and look, because the secret is hiding right there in the numbers.
And there it is, the secret code for any prism in the universe. If you just know n, the number of sides on the base, you can figure out everything else instantly. The number of vertices is just n times 2. The edges, n times 3. And the faces, that's n plus 2. This is your geometric cheat sheet. No more tedious counting needed.
Okay, now that we've completely cracked the code for prisms, let's turn our attention to its more famous, and let's be honest, pointier cousin. It's time for Act 2. Let's meet the pyramid.
Now, the pyramid plays by a totally different set of rules. For starters, it only has one base. And instead of those rectangular sides you see on a prism, all of a pyramid's sides are triangles that shoot upwards to meet at one single dramatic point. We call that point the apex.
All right, you know the drill by now. Just like the prism, the pyramid has its very own secret code, its own unique mathematical fingerprint. So let's put our detective hats back on and see if we can crack this new case.
Here we go again. Let's look at the classic square base pyramid, so n is 4. For that, we have 5 vertices, 8 edges, and 5 faces. How do these numbers connect back to the number 4? The pattern is a little different this time, but it's definitely there, just waiting for us to find it. And boom! The pyramid's secret code is cracked! It's so elegant. The number of vertices is just n plus 1. That extra 1 is for the apex, of course. The edges are simply n times 2, and the number of faces is the same as the vertices, n plus 1. A totally different code from the prism, but just as simple and just as powerful.
We've decoded them both. We have their secrets. Now it's time for the final act, putting them head-to-head in a direct comparison. This is where we lock in the differences for good.
So what's the final verdict in this showdown? It's actually pretty simple. Prisms have 2 bases. Pyramids have 1. Prisms have rectangular sides. Pyramids have triangular sides. Prisms are all about those parallel lines, while pyramids are defined by all those sides rushing up to meet at that single pointy apex. That's really the whole story, in a nutshell.
Okay, so this is all really cool, but why does it actually matter? Well, because when you have these secret codes, you can start to think like a geometer. You can solve puzzles that might seem impossible otherwise. Let's check out a couple of pro tips to see what I mean.
So here's a classic puzzle. Imagine a tiny ant is on one corner of a box, and it wants to get to the absolute opposite corner. What's the shortest path it can take? Now, your first instinct is probably to have it crawl along the edges, but that's a trap, and it's the wrong answer.
The secret is to literally think outside the box by unfolding it. When you flatten the prism out into its 2D blueprint, what we call its net, the solution becomes completely obvious. The shortest distance between 2 points is always a straight line. It's this brilliant, elegant solution that was hiding in plain sight the entire time.
All right, you ready for pro tip number 2? It's time to play detective. With the secret codes we've learned, you can actually identify a mystery shape using just one single clue. You ready to give it a shot?
Okay, here's our puzzle. We have a mystery pyramid and the only clue is that it has 10 edges. So what is it? Well, we just pull out our secret code. For any pyramid, we know the number of edges is n times 2. So if 10 equals n times 2, a little quick math tells us that n must be 5. And a 5-sided base is a pentagon. Case closed. It has to be a pentagonal pyramid. See how powerful those codes are?
So, we've cracked the codes for prisms and pyramids. But that just makes you wonder, doesn't it? What about all the other shapes out there? What elegant rules are hiding inside a cylinder, or a cone, or even a perfect sphere? The world is absolutely full of these hidden patterns, and the best part is, now you know how to look for them.